All right. All right. So today we're going to be donning your lab coats, get your tester beakers out, safety glasses on. We're going to be going over a little bit about product experimentation, a little bit about myself. I am a developer experience engineer at LaunchDarkly. Outside of my day job of building tutorials and documentation and helping people understand what exactly we do, I'm a rescue dog parent. That is a very cute meme I made of my dog. And I'm a stand-up comedian here in New York City as well. So we do some really cool, weird AI shows and have done a lot of open source AI work as well. But I always like to give people a roadmap of where we're going today. So first off, we're going to go over the science of decision making. So this is going to be really an overview of what do you think about when you talk about experimentation, how can you run experimentation in your organization, and how can you use it to make better decisions in your day-to-day process. Then we'll go over how to set up an experiment. We're going to go flip back to that scientific process, but show what it might look like also inside of a development process. And then lastly, the so what. It's really great that you ran an experiment. I'm really proud of you for making decisions, but why are we even talking about this here at today's meetup? All right, I warned you, this is crowd participation work. Here's a riddle. I want you to shout it out when you can figure it out. I'm not what I was, and I'm not what I will be. I can break you free, yet some fear to see me. What am I? Not time. Not metrics. A few more moments. Open source project. No, not an open source project, but I like where your brain's at.
Negative results?
Not negative results. Weird change. Anytime that you're building a product or anytime that you're working on something, you're creating a change. And with every change, you have different things that you should keep track on. Was it a good change? Was it a bad change? What's a change that we made in software this week or open source projects? Did we merge a PR? Did we make a bug? Did we not make a bug? Anybody got a cool change they want to share that they did this week? I broke a demo yesterday. That was pretty exciting. Yeah, breaking stuff is part of building. Any other changes that we made this week? Any changes we're thinking about making? Fixing a broken cluster, love it. Now, when we get to talking about experimentation and the science of decision making, we need to remember at the core we're thinking about changes. So I would argue making decisions can be really easy. You all decided to come here today, that was a decision. Decisions happen whether you like them or not. So if you decided, hey, I'm not going to do the thing, well, you guess what, also made a decision. Now, we have to ask ourselves, are they the right decisions that we're making? Are these a decision that has an impact, or they don't have an impact, or are decisions that are related to our core goals, or not? So how do we think about making decisions? What decisions did we make this week, and what was our process for going through to making them? You guys, why did you guys choose to come to this meetup today?
I've missed 10 meetups in New York and glad there's someone coming back.
Yeah, that's a good one. Yeah, they're glad they're coming back. Awesome. There's free food. Awesome. Great. People are all right, I guess. You know. Interested in learning something new. These are all great decisions and like how we made them. Now, I don't know that many of us kind of go to the drawing board and take a selection by committee for our decisions, but you know, sometimes decisions are kind of just made arbitrarily. We just kind of do something. So there's a running joke. There's a XCKD comic for every situation. We all have heard the phrase, or may have heard the phrase, don't reinvent the wheel. And I love this one. It's like, we don't want to reinvent the wheel. We just Google image search wheel, and then whatever image comes up first, we slap it on the car. Decision made. I'd argue that's maybe not the best way to think about it, of making a decision when it comes to wheels. But, you know, as he says, they've all been pretty good so far. So how do we know if the decisions that we made are a good decision? So going back to our decision to come here, how do we know if this was a good decision or not? We'll know later, but What are we gonna wake up and be like, I have a 4 spreadsheet analysis on, we're gonna make a nice little query the database. Yeah, did or didn't meet our expectations.
By the number of people talked to you from this event.
Yeah, maybe it's like you're coming and you're like, I want to meet at least 5 new people. So did you talk to 5 new people? We all will have our own frameworks for deciding what makes a meetup a success or not. Maybe you learned something new. Maybe you found out both Jen and I have purple hair and that was a cool fun fact you took from that. We all have our own decision frameworks. I quickly asked a bunch of people different ways you could decide to make a decision. At work, we could just let leadership do everything. That's one way. You could hire a bunch of experts and just say, more power to you, let them do it. Have a lot of internal debates. Have you guys ever sat in a call where it's like been like 3 years to get to a decision process? That's a way of decision making. Copy the competition. So, so-and-so there overdid. I feel like everybody's doing that with AI right now. It's like every new product is an AI feature. Why do we need an AI feature? Because everybody else is an AI feature. You could roll a dice or flip a coin, or you could not make a decision and have the decision made for you. These are all ways to make a decision. I didn't say they were good ways to make a decision, but they're ways to make a decision. So I do know this is a data science meetup, so we probably should make data-informed decisions, right? Last we checked. So here's a quick little run through of a data-informed approach to making decisions. 1, set your goals. So if you're like, you woke up in the morning, we'll go back to our meetup example, and you were like, I want to meet 5 new people that are working in open source data science today. If there's a meetup today, I have a chance to meet 5 new people. Goal achieved. Yes, no, it's a binary. Always make sure that you're avoiding outcome bias. Maybe you came to this meetup and you met 5 people, but none of them work in data science. You succeeded your goal, met 5 new people, but if they don't work in data science, did you really succeed your goal? Thinking about the way that we choose these approaches can help us make better decisions, make better experimentations. And lastly, have a transparent and objective criteria for decisions. So when you're making a decision, whatever it is, whether it's attending the meetup or not, having a pretty clear rubric on how you make the decision. One of the companies I used to work at previously, we used to always have async decision docs. So on the doc, it was like, this decision was made on X date, and here's why. And you could read the notes of like the 3 discussions we had to make the decision or the data that pointed to the decision we made. But it was a really nice point in time to be like, hey, because if you guys have been at an organization, especially an organization that's been around before you were there, you're probably like, why do we do this at this organization this way? Right? Or there's that one thing that someone installed and you're like, why is it sitting here? It's always nice to have like a decision doc to go back and look at. Experimentation allows us to make these data-informed decisions. Is A better than B? Should we invest in this or that? Now, we'll get a little philosophical. We'll throw some philosophy in this. Doubt is not a pleasant decision, but certainty is an absurd one. When you're making a decision or choosing to develop or not develop a new feature, you're never going to be 100% correct in what you know. There's always going to be that error of doubt. How did you invest your frameworks? Like maybe we all came to this meetup and we decided, all the speakers decided to go rogue. I don't know. Maybe it was really raining outside and you got caught in the rain on the way home. If you sat at home and you didn't come to this meetup, if we're using that decision as our framework today, and you didn't come to the meetup, would you know the results of the dishes, how this meetup went? We just sat on the wall at home. Someone could be like, yo, Elon Musk walked in and told us a bunch of stuff about what he's doing with that bird site. But you wouldn't know unless you'd have to kind of do some more work to find out. But as many data folks know, as many people who have worked with data know, there's some hard truths we have to deal with data. Data's sometimes just as biased as the people who set up the data. 1, data is incredibly important for all companies. I'm pretty sure that we've all had been told, check out that dashboard, or what does the data tell us? You've all probably heard those things said. But data is only really helpful when it's used for an outcome. I took a data science course once, and they always said, love your dashboard, but what does it mean? 9 times out of 10, if you're just looking at a dashboard, you don't know what that means, what that's doing, or the impact of that decision. It requires further context. Why are you measuring something if you're never going to look at that thing and improve that thing? And then lastly, data analysis shouldn't happen within a silo. Many times when we think about new features or products, we often think that they just impact one little small part of the business. But again, just like our example when we have grandfathered in tech from another organization or some legacy decision that's been made, the most important part to experimentation and data is people. At the end of the day, you are impacting one another, you are impacting the tools you build, and the only way to get better decisions made is to talk to more people. All right, you guys ready? We're going to start the actual experimentation part of this. So what does this look like from an experimentation lens? How many people remember the scientific process from like 3rd grade? Yeah? What's the first step of the scientific process? Hypothesis. Awesome. What do you do after you make a hypothesis? You test. Awesome. What do you do after you make a test? Record the results, and then? Yeah. See how close did your results, did this experiment make sense? Awesome, that's the end of my talk today. You guys are all pros. All jokes aside, we're gonna show a little bit more on what that looks like from a work perspective. So again, define the question, gather information of resources, form that hypothesis, analyze your data, draw conclusions. That so what stage you're publishing for peer review, go ahead and publish, and then retest it by a third party. Congratulations, you all just got a new job. Okay, you can high five in this economy. Congratulations, you just got a new job. You guys are like, I'm pulling teeth in class again, okay? I teach students on the side, but like, come on. You guys have just been hired to my very cool merch store. It's gonna be named Cool T-Shirts for You. You are now my analysts for this experimentation process. You are now all data analysts for the next 10 minutes, or when this talk is over, then you're getting laid off and no, you're not getting severance. So I promise I won't do it by Zoom though. You're all in person for me to lay you off. So for the next 10 minutes, you guys are all data analysts at my very cool T-Shirts for You company. Let's pretend we did some initial research and I'm launching my e-commerce store, and I've got 2 really cool ideas for my product display page. I have product display page A that's got one layout, and I got product display page B that's got another layout. And I want to increase the number of times someone clicks that add to cart button. All right? You tracking? What hypothesis might we craft? What would this look like? Done some research. We believe probably that product display page will impact a metric, that add to cart button. So if we think about this, our idea is always an independent variable. So that's something that we change. So that's always, that's the thing that we're testing, right? We're going back to y equals mx plus b. Back to like what, that's 9th grade algebra. Then you have a dependent variable. So depending on the idea that you have, maybe you launch a really cool product display page and it has a jillion animations and bells and whistles, but it takes 35 minutes to load. Probably not so great for that add to cart ratio. So I'm gonna predict my add to cart is gonna go way down. So again, we've done some initial research that improved product display could increase that frequency. Going back to our forming the hypothesis and skipping along because I know we're coming on time, all this stuff, but it's product display page B will improve our add to cart ratios by 27%. There's a couple of things I want us to notice there. We believe, so that idea or that independent variable is put right in front in the beginning. And I want you to notice the fact that we were very specific with the number, that 27%. So we weren't afraid, we just didn't say improve. Because improvement by, if I gave you all a nickel more on your paycheck, would you really care?
Yes.
Yeah, 1 nickel, 5 cents. Sure. He's like, he's
I'm
gonna
a
be
trained
like,
economist. So.
perfect. Yeah, yeah. He's like, we're doing it.
Just remember, it's 3 cents after taxes.
Yeah, you gotta factor in taxes. We're already getting. So maybe you are like, yes, I do. To me, that nickel is so significant. But to a company, and you're like, I spent 3 months on this project, and I saved the company 5 cents, and you're like, whoa, 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 whoa. But what about the 3 months you spent making this thing for my 5 cents? It's not a very good experiment, right? We're forgetting to put the right outcome with it. So a couple words of warning here. The Harvard Business Review reported that most organizations run less than a few dozen experiments annually. Meaning, we just kind of make decisions. We don't know if they're good or not. We don't evaluate them. We just kind of go with our gut. That's fine. That's a way of making a decision. But is that the best way of making a decision when you have things like money on the line or timelines or projects? Why might we want to make a better decision? The next one, again, is going back to our nickel example. Don't be afraid to swing big. If you're telling everybody, hey, I want to run this test, I want to run this experiment, many times a stakeholder who's like, dude, you're on the clock, buddy. Like, don't be taking up all my time just running this experiment and forgetting what the end goal was. And are we actually further from that end goal? So again, looking back, that's why I chose 27% very randomly. Sometimes this can be influenced by previous research and other stats, but don't be afraid to swing big. So, all right, now that we've got it, and we're going to talk about it through the lens of software. So again, we're going to, if you are in a LaunchDarkly, we treat experiments by an event trigger. So it says basically what happens, and I believe I have a code sample here. Everything that happens after this LD client track is when you start to see, hey, we're going to get the context of that situation. So setting up a tracking event. Then we're going to be getting a context situation. So LaunchDarkly takes context into page. You can start to dive in and be like, I care about people in this zip code that are running on this type of browser. We can start to get more specific with our data and dive into that. We can start thinking about it. And then I put in logs because I like running logs and I'm a weirdo like that, but you don't have to. Oh, it does run and there's other ways of testing it. But this is just one way of tracking it. So what it'll do is it'll take everything from that tracking event and follow it through to see that. Which, if you're running it in LaunchDarkly, creates this little type of database on your experimentation. It does kind of run through, and then at this point is when we can be like, great, we saw this one is kind of pretty even. This is a great little dummy data set that I have, but this is pretty even. So your probability to be best, we have that control group and our 3 options here, or yeah, we've got this V3 you can see really has that 51%. I'm realizing that's very small on my screen. So that is probably very small on your screen as well. But we can start to see what one has the best probability. Now that we've done our experimentation, so what? What do we do now? We have a version that's the best. What happens now? Great talk, ship it, done, end of day, right? Try to beat it. Yeah, I like this. So again, experimentation in like product development is an ongoing process. So you'll notice I made this a nice little wheel. We start with research. So what problem do we want to solve? How do we want to think about this through? Then we implement a change or we implement an experiment. We go, hey, A is better than B. We're going to test it this way on this percentage of our audience on the site. I want to test it 100 different ways this way. Great. From there, we're going to do some research. Like let's figure it out. Did that actually work? Are we running the right experiments? Are we referring back to our hypothesis, right? Maybe we did all this experiments, but we ran it during the holiday season and one product display page was super holiday related, one wasn't. It was the wrong holiday. One had terrible typos. Maybe a link was broken. Making sure that we're testing all of the right constraints and setting up so it's a fair experiment. Then we're developing our findings. What happened? Why did it work? And then back to that research phase. For a never-ending cycle of rinse, wash, repeat. But as all things in life, nothing always goes perfectly. There can be a few pitfalls with this. Our first one is never asking enough questions. So when someone, I think we all have been tasked at work, like, build me a better XYZ, right? Everybody's like, build this or make this change. How many times have you like done it and then you end up doing more work because that actually didn't solve your problem? We've all been there. So challenge the questions. Does this experiment actually relate to the goal that I want to achieve? I could say, I want to run an experiment to see if I want to create more add to cart clicks. However, I'm not testing anything related to the cart at all. It would just be like days of the week, which doesn't really tell us a lot of things. The next problem we have, which is definitely something we can definitely see in larger organizations, is too long of analytical cycles. Awesome, love that you ran it for 6 months, but our entire business model changed. I've actually now pivoted to the helicopter industry instead of t-shirts. My information and data on t-shirts is not relevant to helicopters. Probably need to go back and revisit that drawing board. And lastly, our inflexibilities and possibilities or potential solutions. So does this actually work, or we can only do it one certain way? Part of experimentation is being wrong. Being willing to take a risk and be wrong on something. But that's a quick little tip. I'm happy to take, I think we've got, I don't know, time for, I'm looking at Jen because she's like, we'll go like 5 minutes here on questions if you guys have any. But if not, I'm happy to geek out and give the time back to the room. Of course, thank you. Yeah.
What's something that you got wrong that you actually learned a lot from?
Oh, I love this question. So what's something that I've gotten wrong that I've actually learned a lot from? One of the things I did see recently, I'd like to say, so I am in-house at LaunchDarkly, so I kind of do our tutorials around experimentation. One of the recent ones that I did see is actually this e-commerce example. So I actually used to work in e-commerce as a product manager before even doing this. And it was a headless e-commerce startup. The number of tooltips I thought. So we had a no code and a code option, right? And I feel like I was like, we're going to put so many like tooltips to help people explain how to use our editor, yada, yada. No one cared. They were like, they actually wanted less choices. Like the versions that had more choices was terrible, but it also gave us a lot of insights. Like people who are using this from a no code perspective, this platform, they don't want to dork with it. They just want to like get the thing working and be out. But here we're like thinking and trying and building and spending a lot of time to, do you want a font editor, a text editor? Do you want to be able to embed things? But it tells you a lot about like your product. So yeah.
How long do you have to run an experiment?
Great question. So with LaunchDarkly, and this is specifically within the LaunchDarkly realm of things, we usually do recommend, I think, about 4 weeks as like an average cycle. However, the way that we structure our data, you can stop it at like any time. Just make sure like a 2-week cycle to get like all 5 days of the week. And then also being mindful of the time of year. Like between Christmas and New Year's, how many people are going to have regular behaviors online? Probably not many, right? Like I'm watching a lot of shitty reality TV show. Not saying that I don't watch that every day, but probably watch way more of it when I'm not working. And so having that fair time assessment is really good. I've seen companies determine they're running experiments based on, hey, it'll take X weeks to implement the change. So we need to have the implementation of change. The other perk of using it with LaunchDarkly is it is paired with a feature flag. So you can be like, oh, this one worked. Great, automatically deployed. So don't have to worry about that. I've seen organizations do it based on design cycles. So how long does it take you to design a new thing? I've seen organizations kind of just do it on an arbitrary, like, yo, 2 weeks. That's it. So it really does depend. You will notice when you start running an experimentation for a longer period of time, you don't necessarily get different data. Like the habits are pretty consistent at a certain point. They've kind of leveled out.
What is the maximum amount of data that you guys have been able to load in these experiments?
Like, what do you mean by maximum amount of data?
Like terabytes, petabytes?
Oh, I would not know on the top of my head. So I think it also depends on like how many are you running or like,
Okay.
yeah. So hit me up if you got specific, like I can look into exactly.
Well, I'm trying to think like what your customer would be if you would do an experiment on Amazon, of course you would be doing more streaming type data. The one that you had for the t-shirt company as well.
Yeah, it's all ran via like API calls. which is just like a tracking event. So it really depends. Like I've seen some people who are like, I'm running it for 3 months or 3 times, and it's like still is able to handle that load. But it's just tracking number of track events. I'd have to look exactly on the amount of data. That's not something I would look on the top of my head, but yeah. And there's a question here. Yeah.
I did.
Let's do last question. This one.
All right, last question here. You get to be the golden last question, Mike.
Excellent. Does LaunchDarkly have any features to email you when your experiments have been running for too long?
Yep. So it automatically tells you like once it's already in there, and it's like, it'll be like, hey, we think we have a result, da-da-da-da. And you can set it up so if you're doing it to just a portion of your audience or an entire audience, you can say, great, once you have a result, I want you to expand the amount of people that it's reading or hitting, or slightly change the parameters. And then it'll even save all the iterations that you run. Or if you're like, hey, once it hits a result that hits this level of satisfaction, like we know that this one is definitively better, you can set it up to automatically implement the change. So it's like, great. If something is going really bad and it's like you did something, you made that really slow load time page, it'll let you know like, hey, experiment is not going so hot, and it'll automatically kind of roll it back for you.
Oh, nice.
So it has kind of those like built-in cool features there.
That's awesome.
Yeah. So learned something new today. But without that, I will give it over to our next speaker. Woo!
Oh,
your slides were too nice.
Yeah. I was like, what?
Yeah, I don't know why I want this, but I want this. Now for something completely different. My slides are not very nice. Mine may have some cats. I'm going to try to skip through my slides as fast as possible so I can get to the demo, which is more interesting. At least to me.
Yeah, but it's a live demo?
Live demo. I don't do fake demo. Live running on the laptop with a database, a streaming tool, Kafka, and Flink all together. Is that dumb to do that?
First live demo that I ever experienced that actually would be going 100%.
Well, it really did the internet break. That's the problem.
Yeah, that's often the case.
That's why I try to run everything on the laptop. I don't know, it's a good place to stand that's not in the way. I'm from New Jersey, so I appreciate the Edison bulbs. I'm very close to that. This is me. Well, thermal me. This is my cat. He's eating all the streaming. We're going to go through this quickly. I'll do an intro, show you some use cases, do a very quick overview, go over 3 of the largest projects ever built in a minute, and then go to the demos. This is New York when it was bad outside. I have a demo that tracks the air quality real time, and it's never gone above like 0.1. And then during this time, I live not too far away, it went into the hundreds. It was always in the red. So now when I run the demo, it's like, so I don't run that demo anymore. We need more bad air quality for that one to be good. I'm tracking real-time transit. As we get later in the day, there's going to be less data. So it's better when we run this a little earlier. I've got Halifax, MTA. You're like, why'd you pick these random ones? I was there, so it's nice to show people their local stuff. Then I found out that someone put a list of every publicly available transit system in a GitHub. So I real-time read that at a GitHub and then call every single real-time transit system feed in a row on my laptop. How wrong could that go? You know? And running the slides. So we'll go through that. I figured out I should probably cache that because you know how frequently new transit systems come online and put a real-time Google feed? Once a year, if you're lucky, once a decade. So maybe I shouldn't read that every second. They'd probably get mad at me. So I figured that out a couple days ago. I'm like, oh yeah. Not every piece of data is real time. I don't want to accept it, but it's true. So I'm caching some of it in. Shout out to my friends at Ivan. I put it in their Postgres. but I'm also running Postgres on the laptop because, you know, if you don't run it on the laptop, network will go down and things will happen. Now, we can also add to these real-time feeds deep learning, vector databases, machine learning, just because the more you run on the laptop, the better the chance of success is. I've got articles on this because this has worked before. It has worked. NiFi came out of the NSA because they had a very unique use case. They needed to be able to track any kind of data real time, even if it was on, say, a system that was going to only live a minute, because in that end of that minute, it would blow up. So to be able to track anything real time and change it in the middle when all of a sudden someone says, oh, that's not working or that didn't make it there, switch to this other system real time. But the people who are writing these apps, they're not developers. So it needs to be drag and drop, but still needs to scale out to any size and work with structured data and unstructured data and semi-structured data. So this is my favorite open source project. It is kind of streaming. There's a big debate on it because it's not Kafka, it's not Pulsar, it's not Flink. It is not designed to be the channel for the data, designed to get stuff in that channel, get stuff moving, regardless of where it is. And it's a pretty mature project at this point. The new thing I'm showing today is we finally allowed you to extend it with Python, which is big for data science people. It's been Java for the first 10 years. We just added Python. Well, it's about time. I mean, we could call Python before, but it was kludgy. Because NiFi could do anything if you're willing to do it with a little wince. Because it's not pretty. We'll get through the slides. Something very unique, which will help you in doing experimentation, is provenance. Everything you do within this NiFi, you get an audit record at each step. So I get things in from a REST interface. I know the size, when, where, and that data is actionable. I could take metadata about my data and use it as if it was first-class data. And I could use that to decide, oh, what do I do next? And it keeps a rolling tab of that, which could be encrypted, could be sent to a database, could be sent to Kafka or Pulsar, could go wherever you need it to go. Because sometimes it's more important to know how the data got there, what happened to it, who changed it, or did it change? Especially if you're paying for the data. Hey, I paid for 5,000 records. I got 2,000. I could show you it didn't arrive. I could tell you when, how often, how I called it, every HTTP library that touched it, all those kind of things. And if you need to do stuff that looks like a database, it is really easy. It supports records. So if it looks kind of like data from a database, we can automatically read it so you don't have to write SQL if you don't want to. You don't have to define what the record looks like before or after. So I could just point to random systems. If that's structured or semi-structured data, I could automatically read it, know what it is, and immediately convert it to something else. So I could read in CSV and convert it instantly into Parquet, or read a log file, turn it into Avro, then push it into Kafka with no code, don't have to know what the format is, and it could change on the fly. And I could change the sources and syncs dynamically while I'm doing it, either with code, drag or drop, or with command line tool. I do it drag and drop. Kafka's cool, you put data in it, sometimes it comes out the other side, it's usually fast. Flink is really cool, but I could spend 2 days on this because I could use query, regular SQL, pretty powerful SQL, calcite, so the same SQL as Phoenix and a lot of other tools, against real-time streams of data as well as static streams of data. And it doesn't matter if it's Pulsar, Kafka, Postgres, a lot of different formats, and do things like join them in real time, do them over windows of data. A lot of people use this in credit card transactions, including most of the credit card processors, because this can happen at a tremendous scale. Like Alibaba uses this for Sevens Day, when you can get trillions of records coming through in a day. This will not fall down. There's people running 25,000 Flink nodes. It scales massively, or just runs on your laptop. So it's a little overkill to run an entire streaming platform on your laptop, along with the slides, along with Google Chrome, which is more resource intensive than the entire streaming platform that I'm running. And if you don't believe that, you've never run too many Chromes. Yeah, it's. I wish it wasn't the case.
Google Chrome, it's the commercial stuff that it
Yeah, I mean, I wish. I've tried other browsers. I mean, maybe I should just implement a browser in NiFi. So I'll show you a couple of the demos. You can see it all right. So what this is not a diagram of the code. This is the live system. This is what it looks like. This is my coding. This is a Python script I wrote, but it's wrapped as what we call a processor. And in there, this one is the feed for the vehicle positions for Halifax in Canada, which is a nice city. I recommend it. They have a castle. So what's unique with NiFi, besides you can put cool little color post-it notes, is that this is running real-time or scheduled, whatever you feel like, and it is dynamic. You can move things around in a version-controlled, even position on the screen, which is a little weird, but you kind of need it because otherwise they'll just sit on top of each other. So I'm not going to run this real-time because I push my luck if I run every single system continuously the whole day, because there's a lot of memory. So I'm just going to do something, sort of an experiment. NiFi lets me run things on a schedule like cron. I could even use a cron tab in there. Or I can run it continuously, run it every so often. Or I could just run it once when I just want to run it, once in a while. So I sent a command to this Python code to get me the GTFS for Halifax that you saw in there, and return back the records as JSON.
What's the GTFS?
GTFS is a Google standard, which they pompously put the first letter as Google. It is the format that they use in Google Maps. So you could see the point there. All the transit systems want their things to show up in Google Maps. So you go, I want to take the train here, and you see it, and it has the real-time trains, because they're grabbing this GTFS. I'm grabbing the same GTFS and just converting it to something I like, because GTFS is weird if you looked at the file format, sort of binary. So this is that provenance. So the data came through. Is this the real time? 712. That seems probably right. This is the metadata about one of the files of JSON that got pulled out of that. That's the metadata. Ooh, it's a big file. We'll take a look. This is the JSON produced from one call to one transit system for vehicle positions. So that's just running through the system now. So I split it up. Instead of having one big JSON, I made it into smaller ones. Then I didn't like the format that they use because I'm picky. I wanted it in a certain format. I wanted to change the names. So this is how I can look at a file that's coming through in real time and pick out fields that I like without changing the real data yet. So I could have that data unchanged, make a copy of just the fields I like, put it in metadata that follows that record through the system. We call it a flow file. Inside the flow file is the data that you got from a system. And we don't have to change that. I could set up a bunch of attributes that are metadata with it. And for here, I'm putting in all the fields I like. And then I'm going to throw away their original file and rebuild it with just those fields I want with the names I want. Now, there's other ways to do that. I can run SQL on it within the tool, but that's one way. Then I'm going to add a timestamp to it, to whatever the records are. What's nice is I can change, let me show you something cool. So I just stopped this live flow, but we only had one run going through. I'll run another one. So while that's happening, I stopped it. You could see instantly data's live because I stopped it. Are we going to lose the data? No. Data is stored within configurable queues between every step. So if something goes wrong, like say this breaks, like I'm calling Amazon and Amazon's broken, or our network's broken, or the person who paying the bill is broken. So they tell me, Tim, we have no more Amazon. We ran out of money. I can't say that's ever happened, but it can. So instead of doing that while the data's sitting there and more could come in, I'll just put it somewhere else and do that real time. And then when they go, Tim, we fixed it. I don't believe you, but we'll go with that. Now we go back, we'll go live again, and then we could restart it. And the reason why I originally came in here is to show you how easy to change things. So I'm reading JSON, but I could read different format. There's also a reader we have that looks at the data and says, oh, I think this is CSV, I'll read it as CSV. Or let you put hints in there to say, if it ends in CSV or has this kind of MIME type, use this reader so you don't have to hard code it. Because sometimes people change formats they give you or how many fields or how many records you get at once. So if it was XML, it wouldn't matter. I could also, I'm adding a schema dynamically to it in case somebody needs it. Like Flink and Kafka want to have a schema. I don't need one in NiFi, but other people need it to be able to do SQL, which makes sense. I want to know the field names, the types, the size, are they nullable, those kind of fun things. So we turn it on. What else are we doing? Here is some example of SQL. I'm not doing anything fun here, but if I get data with a null in it, just going to throw it away. There's no value to that data. It's not. And here is I can make a decision if I needed to change it to another format. I could do that while I'm doing my SQL. I could also don't have to have one SQL. I could have multiple and use them to route my data through the system dynamically, because maybe a couple of fields should go to Postgres and a couple should go to S3 and some should go to Kafka, you know. And then I want to take the route, which one is this one? I want to take the route and take that ID and convert it into the long name for it without having to do something funky. This processor looks it up, looks that ID up in Postgres and caches them and brings back the long name and adds it to your data. So that's sort of real-time ETL. And then when I'm done, I push it to Kafka. I could push it to Pulsar, for my Pulsar friend there. And if you'll notice anything, did we say what fields are in there? How many fields? How many records? Doesn't matter. I could push any GTFS, and I did that in the next one. So I'm like, well, could I write a system that does MTA? How are they different? I'm like, they're not that much different. They're pretty similar. Though the MTA has a lot of data, surprisingly. So we could do the same thing. And I'm like, didn't I write that for Halifax? And then I'm like, didn't I write that for Brazil? The Brazil one's a little hard because their API is in Portuguese. And it's Google auto-translated it, but it translated the API wrong because you can't translate people's API fields and expect that to work. So I had to dive through the Portuguese API, which is surprisingly difficult. So theirs is a little different. I found out some people have little tweaks in their API because this one needs a login. Most of the other ones don't. So I've got to log in, set a format, and then do that. But otherwise, same stuff. And then I'm like, is there a generic way to do this? Because I've done this already 3 times, which tells me I did something wrong. I shouldn't be writing the same code. I mean, this is a lot of boxes I put on the screen, man. That's a lot of work. It took me almost 2 hours to build a live transit system. That takes too long. So I decided I'm going to download every transit system in the world and just do that. So I don't have to write any more of these. Though I still have to write some of the ones that have a login, because everyone has a different way of doing a login. So what I did is, as I told you there, is probably not a good idea. I downloaded a CSV from a GitHub from there's a transit association connected to Google that publishes a list of all the GTFS feeds in the world. So I download that CSV. Now I was downloading it every minute. GitHub probably was mad at me at that. I have been banned from a few services because despite running on a laptop with all this other things, I could generate enough traffic to get banned by Imager, YouTube. I'm not saying random ones. This has happened. Because this will literally be able to do 10, 20,000 REST calls a second on someone's generic Wi-Fi. So I learned maybe don't do that, Tim. So what I did, actually yesterday I thought of it. And because I remembered with Ivan with Postgres, I'm like, oh, free Postgres, you know. Thank you for free Postgres. I'm going to use your Postgres. And so when I grab it, I just push it to a database. So did I create a database table and I designed it and picked all the fields? You probably should do that. I did not do that. I just decided to pick this option here, create the table. So first time, if there's no table, creates a table. Reads the schema that comes in, and then makes it insert into the database. And pretty easy to do that. And none of the fields have changed, so it's kind of silly to do this. I could take a real quick look in here, and it just puts the systems in a table for me. Not too exciting. But now I don't have to, every time I want to grab every transit system, grab that CSV and get people mad at me. So instead, I'll just read. What I have here is, this is not the best way to do it because this is waiting for new records. And there's probably not going to be too many new records. With NiFi, I can query any database. And it's going to wait for me until something changed. And I could check the state and nothing changed because it's the same data it's always been. So I could just stop it and I'll go to my state here and clear it. I got to figure out how often I want to time this and how often should I check the database. I don't know. I still got to think about it. I don't know how often transit systems get added or removed. I mean, there's probably not too often. So this one, instead of doing it per system, this is generic. It takes whatever URL it is and routes it based on what type of transit system. GTFS has 3 different types. So I route it based on the type because it's slightly different. But there isn't too much work here. So I'm just going to load, there's 189 systems that have trip updates. So I'll just parse all those, and that's why I had the Kafka up. It pushes it to Kafka, and why I push it to Kafka, again, more steps than I need to, but to show you something, this is Flink SQL. I read real time from that Kafka, and I push it out to a materialized view. Materialized view is just REST JSON. Why I did that is so I can create a live transit map that's just HTML. And I don't have to read Kafka. I could read Kafka from a web page, or maybe put it in a Spring app, or there's 50 other web page front ends. But here, it is really basic, and I can get a live map with all my different spots. This is Halifax. This is Sao Paulo, which has a lot of traffic. This is MTA. Let's refresh here. And let's see where we are. Yeah, there's a lot in New York. Are there any near us? Let's see. I think I went too far up here. Oh, I went to Staten Island. Never do that. No offense, no offense. As someone from Jersey, they're the only people I can make fun of, so I got you. There's nearly nothing else. Let's see. Where are we? We're around 46. Did I go too high? We're somewhere around. Oh, we got no bus, man. Oh. If you're in a hurry, there's a bus going to be here real soon. So if the talk's boring, run. Try to grab some food while you're doing it. So that's, well, how much time? We got a couple minutes. We should probably do some questions. I know it was very straightforward. Not much happened here, but there might be a question.
Are your slides on GitHub?
Yes, and all the code is. And there's articles around each one of these segments with the source code, how to implement it. And again, you probably don't want every transit system, because if you look at the maps for all transit systems, I put in a couple so far. You probably don't care about Ontario and Halifax and Michigan. Oh, I wonder if there's others in the world. I don't know how many systems have processed. Oh, I didn't even look.
And this is just local transit, you're not also tracking Amtrak?
Amtrak, it doesn't have GTFS. They have a different API. I've got other programs that track planes, trains. I got New Jersey Bus, which has a different API. They use RSS. It'd be nice if everyone used GTFS, then I'd be done. There's a GTFS one. There's a Transcom that covers 3 states in the area, and they give us real-time highway. But they support a weird format, so I grabbed that a different way. But they give me all the transit data for the highways in New Jersey, New York, and not Pennsylvania. But, Pennsylvania doesn't like to deal with other people. You got to use their separate API, which is also not GTFS, but we've done that too. Transcom is a weird format. Oh, we can also do LLM. Get those buzzwords in there. Transcom, again, very similar, but we're calling RSS, and which is a format of XML. But again, I don't like weird formats. We just make everything JSON. And once it's JSON, I can do whatever I want with it. Again, I don't have to send it to one place or one paradigm. In this flow development, I can go as many places as you want, which I have some people I work with who've made some of these that have 1,000 steps, which makes it kind of hard to follow something that you can't even print out on the side of this wall because it just goes. Because I can go, knew one company that used it to ingest 40,000 sources of data, brought them into one Kafka topic, and then normalized it after there. And you could just do that as many places you want at any step you want to do something. You could put it into any other downstream system you want, again, without writing any specialty stuff. You just have to have a connection to that thing. And that does include, as of recently, now we have some vector databases and, Solar and all those kind of fun things. And I put in a couple of my own Python code. What's nice is whenever you write any of this code and you put this box here, it has all the features of any of these other ones, which means I can run on my laptop or I could run in a 1,000-node server. You don't change any code, and now you're distributed. Now you have logging between it. Now you have the audit trail. Now you have the ability to start and stop things, have a queue in between it with prioritization on it, load balancing, because again, I could run across 1,000 nodes. Sometimes it doesn't make sense to do that, but you could decide that at each step. So say I access an FTP server. I should only have one server call someone's FTP server, because if I have 1,000 nodes hitting their FTP server, things will get weird. So just having one and then have it distribute on that next step automatically to every other server. So it'll break it up into chunks for you based on how you want to do it. It can be prioritized where you say first in, first out, or based on an attribute. So I can set an attribute that says this particular data is priority, send it to our fastest server, or send it to the one that's running on Amazon on a premium instance or has a GPU. You could do this because the cluster can span different clouds, hybrid cloud, all the laptops in a room. It could also run small enough to run on a Raspberry Pi, depending on what your needs are. Very configurable. I think we are out of time. Can we do a couple questions? Or people can ask questions while they're eating?
I mean, that's always a lot more fun, but
makes for better video. Yes.
Is there a way to version the different paths
Yes.
onto the data set so at least I know this set of data was processed through this
Yes.
particular set of paths while maybe a month later we did some
You have every step. We also have the versioning information on each processor, when that changed, what version. The name of each component has a unique ID. So I know when record 700,000, and each record's given a unique ID as it comes through the system. I know when every record was on this step, or if it hit that step. Maybe it failed before that. Maybe it went a different path. So you'll know every step, and you can build up visualizations. We push that to Prometheus. We push that to Datadog, to a database, Kafka, the tin can with a hat, whatever you got. Other questions? And it's open source and just needs, right now the new one needs JDK 21. And you probably should have Python 3.10 to do Python fun. Yes?
So you mentioned that you're writing to PostgreSQL as well as the materialized view.
Yes.
Can you please repeat which things you're writing to Postgres and which to materialized?
Sure. The materialized view is taking a query, sometimes a join, sometimes an aggregate of data coming usually from Kafka or Pulsar, and does that as each individual event happens. So it's not a microbatch, it's a true stream. So as those come into the SQL, it immediately gets acted upon. And that could be sent to another Kafka topic, that could be sent to a data store. Typically for the large credit card people, they send anomalies to a Kafka topic and someone reads that and does something. And this could be at any scale, millions of records. For Postgres, I use that when you saw me downloading the CSV every minute. That's dumb. There's times when you should use a database, when things don't change frequently. Within the Halifax example, before I made things generic, theirs is a little different from other ones because they have a set of static data tables that they make available that has a lot of extra metadata. It's all in one zip file. So I download that zip file. NiFi can unzip zip files. And then I push those. They happen to be CSVs. So I read them and convert them to JSON because I like JSON. I don't really want to see CSVs floating around. And then I read them from that Kafka topic. So I can leave that on. So whenever a change happens, again, it's batch data. It doesn't change too frequently. I push that to Postgres tables dynamically based on the name of the data I read because I'm reading like 7 different tables. I just have to have one Kafka topic to do that. Reads a table. If it doesn't exist, builds it, populates it with that whole lookup table. That's a good use case. And then later in the flow, you saw me with that PG lookup. I looked at that table to get a long name. That's a perfect use case for static database or something like HBase, Kudu, Mongo. I could use any of those. Redis, especially since someone's got a free Redis instance I could use. I could use Redis to pick that up, especially key value would work real nice. And again, that way, when data coming from these systems often doesn't have long names, it's abbreviated because you're getting tens of thousands of records a second. You don't waste time. They give you just IDs. So this lets you do that lookup on the fly, enrich the data. Again, static data is useful. Or to me, a database is static. Even if it changes once a minute, that's batch data to me. Anything else? Or are we all hungry?
You showed a note about when you can recognize new data incoming.
Yeah.
Does NiFi equipped with that? How do you achieve that?
There's a couple different ways. The dumbest way is looking at either a timestamp or incrementing ID, something like an Oracle sequence. That is dumb, but often that works. If that's not available, we could use Debezium, which has a connection to the transaction logs for databases. So when something happens in the database, I can get that log or read that with NiFi. Or I can read it with Flink, or I can read it in Kafka. That's when things get murky. Who should do CDC? That's probably a good 2-3 hour talk. There's a lot of nuances there, but I set up 2 years ago a nonprofit in Africa. They have one server in a closet, and NiFi runs the entire nonprofit because it can host web pages, it can host REST endpoints, FTP, read any kind of data, push out data to phone apps, do everything in itself. It could store things in a cache. You probably should put a little database on there like Postgres, but that could do pretty much anything. Anything else?
A bit of a philosophical question. So, NiFi is very capable. Like you said, you can serve, REST services through NiFi and so on. Do you find people actually doing that, and how does it compare with the traditional programming?
Yeah, it depends on what it has to be data intensive, data driven. When I was in Sao Paulo, the largest bank there told us they got a new requirement that they need to share all new people and all new account information with every other bank in the country. So the way they did that, because they're processing that data now with NiFi and Kafka, they just had NiFi push those events to their competitors and also provide REST endpoints for the ones who want to grab it. Because some people wanted to push, some people wanted to pull. They had it there anyway. Should you replace regular apps that don't have a lot of data? No. Right? There's so many options that have nice little tweaks and other stuff. But if it's a data-intensive app and I want to push to people real time and I don't want to have to add another system that I didn't have, I'm going to do this. Again, data. If it's not data-intensive or your data changes once a year, write a Spring Boot app or Python or Rust, Go, whatever's your favorite. Or if you already have a platform, use that. Use NiFi where there's a gap. It's like a Swiss Army knife. It may not be the best thing to chop down a tree, but eventually I could chop down your tree. There's things that it's best at, but there's things that it will do. It may not be the best choice, like building mobile apps in NiFi, not the easiest thing. Probably not recommended. I've only written a couple. It's really more of that's a cool demo. I only know one company that did that, and they connected it to a smart shirt. And this was a water company. Because they're like, we have NiFi, we're going to use it. I mean, one programmer could write a lot of things with NiFi. Don't have to compile it. Don't have to, testing's a little bit of a pain, but.
Yeah, we have this internal conversation all the time because some people, they swear by NiFi, and essentially every demo they show it's going to be on NiFi.
Once you get it and it solves your problem, you're like, can I put, what if I want to read, can I get live music? And then you start doing stupid things, and look at my back catalog of ideas. I get a live jukebox in there. Is that a good idea? No. Did it work? Yes. Is it a cool demo? Yes. Is that the production system that they should use everywhere they have a jukebox? No.